Right then, today we're going to talk about the different types of points. In fact, we're going to talk about the frogs on the points and the different electrical connections. I want to try and show you how they wire up, how they work, and try and give you a better understanding. This video is more aimed at people that are new to the hobby, but there's one or two tips and tricks along the way that I'm going to show you as well, which a more seasoned modeller could maybe use. So first of all, we have three different types of points. We have an insulfrog, an electrofrog, and a unifrog. Now, I know that's a lot of frogs. What is a frog? Well, the frog is simply the V. The V, just that bit there, that is your frog. Now, on an insulated one, this is what your frog looks like. So, as you can see, it's all plastic at that point. This is an electrofrog. Now notice the difference here. All the frog is actually metal. It's live. These check rails are live. That is what an electrofrog is. And then we have a unifrog. This is the new kid on the block. Now then, if you notice here, it's live to this point. We then have an insulated gap. These bits are live, insulated again at the end. And this wire here is for the frog. So, without further ado, let's have a look at the characteristics of each point and see how they work electrically. Right, so this one here is an insulfrog. As I've said, it's the frog that makes a difference. But let's see what it's like when I put some power. So we'll switch the blade, so it's the truck is going straight on to this end track. So we'll do, in this case we'll have black to the back and red to the front. So the point is going this way. So what it will do is it will give you a red one there. So it gives you a red one there and a black output there. So electrically that will go straight through. Now you're going to say, well, what happens on the other side? Well, you currently have a red there, but there is no power coming to this piece of track here. So that makes this line here insulated. Now then, if I throw the switch like that, what changes then is the fact that suddenly we have no power on this track, and suddenly there is power on that track. And that is one of the easiest points to understand from a wiring perspective. So you got power, as soon as the point changes, it gives the right power at the end. Now this is brilliant for sidings, because when you come to wire up a siding, all you've got to do is put the point across the opposite way, and that will insulate your sidings. A lot of people new to the hobby will use this point. So it's the easiest point to understand, it's the easiest point to wire up. Now then, the only downside of these, there's two downsides. Your insulated part is that long, which on a normal circuit, that's not an issue. You run your trains through, it'll get through it, no problem. Now the problem lies is when you have a tiny train. Something like one of these. What will happen is you'll put your loco on the track like so. Now what happens is it reaches that point, it'll get to your frog and it'll stop. It'll only happen on the short wheelbase locos. On your longer ones, essentially you'll have a pickup on both bogies, so it'll be picking up here. Once it hits your frog, you've still got a pickup at this side. Once you get so far, once that wheel hits that, the other side's picking up. It's only on the very short wheelbase locos you may have a problem. So if you was considering having a slow shunting layout, this may not be your best option. The other slight problem to this is it relies on these point blades. That point blade has to be touching for you to get power out here, and the same on the other side. You flick it, that has to touch. Sometimes what you'll find on a layout is, especially if it's not being used a while, you may get a little bit of muck inside these point blades. They may not be touching properly. You may have to clean them out. Sometimes you may even have to bend the rail a little bit just so it makes perfect conductivity to that rail to make it work. So that is an insulfrog. Right, so from a manual point of view, we have got some choices here. With this, you need no point motors. You can flickily just push it with your fingers, one way or the other. Simple as. Now another option is what we call a wire in a tube. You get a wire. This is piano wire. I will put the size up for you. And this is a tube. And what you would normally do is you would probably have a bit of cork like that, so your point's raised up. Then what you'll do is you mark off on your cork roughly where this blade is, so we're going to say it's about there. So what we would do then is we'll notch some out like that, and on your wire you would simply just bend it over. When I can find my pliers, there we go. So you'll bend that so it's at an angle, so your point might be nailed down, it might be screwed down. You notice there's a little hole there. What you'll do is you will put your wire through the hole, if I can do it like that. So your wire's now through the hole, and you will simply, you can actually use your, this will be glued to your board, scenery over it, and as you can see, once that's glued down in position, you can use the rodding to change your point. Some people still use this analogue way. They still have. I used it on the back of Sway's pond. I haven't, it's what I got, but this is one way of controlling your points manually. Just through a little piece of wire, pull the wire, it changes your point, push it the other way, job done. So that's just one way of actually being able to control your points without actually having to use your finger. So this is a manual way of doing it. Now then, I'll show you another little trick as well while I'm on. So if you're going to actually fit your track down with track pins, these are the typical track pins you will actually get. If you can see, they are very fine, they are very long, and to be honest, they will bend very, very easily. Whereas you can get these again are from Pico. These are a little bit shorter, a little bit thicker, and they won't bend so easy. The difference is, these are normal track pins. These are the track pins for set track. So those are the pins you want if you're having trouble putting your pins through the board. So that's your track pins. Now then, we'll talk a little bit about fish plates while we're on. you've got your metal fish plates, and you've got insulated fish plates. These are the plastic fish plates. Now you're saying to me, you've just said it'll isolate your track. Yes, and it will isolate your track if it's facing the wrong way. But there may be an occasion, well, there could be a couple of occasions when you will need to use insulated track joiners. So let's have a look. One might be, say you've got a circular track and you've got another circular track inside. These are two separate controllers and you've got a crossing like that. What you need to do is where that crosses there, that would need to be insulated. So you need insulators on both pieces, because this one could be, that might be controller 1, that might be controller 2. You should never have your electric mix up when you got two separate circuits. The only other time you may need to actually use an insulated track joiner, this is quite complicated. You might have a track and it might reverse on itself and come back and go like that. Now what happens is, if you look at the electric, it'll start off with the red at the back. As it comes round, comes back on itself, ends up being red at the front. Well, we can't have that. That will cause you a short. So in that circumstance, what you need to do is you need to insulate both sides of the point. You will then put a power feed in here and a power feed in there, and you would power this loop separately from the rest of your layout, and you'd actually use a switch to change the polarities. So it goes red in, and then you would stop your train, you would reverse the polarity of your wire, and then once you reverse the polarity of your wire, it will come out and the red will be on this side. And it's as simple as that. It's just a case of, if you want your train to run this way, you have to reverse the polarity. So those are the only times you'll actually need an insulated joiners on the insulfrog that I can think of at the minute. I'm sure there's other circumstances as well, but you don't really tend to use that many plastic fish plates on these points at all. Very easy. You'll just tend to have a siding, and you just opposite way isolates the siding. Another useful tip is, when you're trying to work out the electrics of a point, work it as though it's from the toe end of your point. It's a lot easier to see what is going on with your electrics. Doesn't matter if it's facing that way or facing the other way. Have a think and see what electrics is feeding into the point and what's coming out of the point, on which circumstance your point blade is switched. This is another way to try and avoid shorts. Shorts is the bane of everybody's nightmares, but with a little bit of thought, a little bit of paper, can easily be worked out. So there you go, that's the tubing the wire technique. That's an insulated frog, and times that you might use an insulated joiner. So let's crack on, and we'll look at electrofrog next. So this is an electrofrog point. Right then, let's have a look at what's going on with the power in this case. Right, we'll have it going to the top first, like last time. So it's going to the top. We've got black and a black on this piece of track. You've got your red and your red. Difference here is all this is electric. Again, it is picking up off these feeds, off your pipe blades, but this time, because this is all metal, you'll get a red feed there as well. Now that bit of track will be red. That will cause you a short. Simple as that will cause you a short. And vice versa. If I switch that point, so it's now coming off the bottom track, what happens then? Put this over like that so you can see. It's now feeding to the frog from the black, and again, that is what happens. So in this case, what you do need to do on electrofrog points is isolate at these 2 points. So here, on both points, you need to have, we call it an IRJ, which stands for insulated rail joiner. The outer 2 will be metal, your inner 2 have to be plastic, otherwise you will get a short on your point. So what you need to do is you need to be able to control this frog. At the minute, it's fed again through your pipe blades. Well, that's not an ideal scenario at all. What I would tend to do is I would err on the side of caution, and I would actually connect either one of these tracks or both of these tracks to a separate wire. In this case, I'm going to call this the frog wire. And what I would do is I will make some form of switch mechanism. So let's have a look here, let's try and draw it simply. So if this is a switch, you've got your red, you've got your black, and that's your switch. When that's feeding the bottom line, that frog needs to be black, so that will be for the bottom, so it will go to the bottom. If I switch the point and it's facing upwards, that frog now needs to be red. So in this case, the bottom track needs to be black, the top track needs to be red. Now then you say, well, how do I switch that frog when my point switches? Bear in mind, this is in a manual context, not the point motors. We'll be covering point motors and frog polarity in the next episode. There's 2 ways of doing it. Now then, first way is if you DCC, it's a doddle. DCC, all you do is you get something called a frog juicer. Several companies that make these. I think the first time I ever saw one was by Tam Valley, and I believe now Gauge Master do them as well. And essentially it's a little relay, so you've got a circuit like this, and you'll have 3 inputs on it, and essentially you'll have an input for your frog, you'll have an input for your red, and an input on the black. What it does is, your train fires up your point. As soon as it hits that frog, it'll say, is this the right polarity? If it's not the right polarity, it changes it automatically between the red and the black, depending on what it needs. And this happens like that. It is a split second, job done. So dead easy in DCC. Doesn't matter, you can still change your point the opposite way. Train will fire through, hit the frog, it'll ask itself, is it right? If it's not right, it'll change it. Bang, job done. DCC, very easy to do using manual point control. Now then, the other way of doing it, and this does work, is you use your wiring the tube method that I've just shown you. And what you do is, you wire it to a slide switch. So you drill a hole through your slide switch, and you put a hole in the top. You would literally put your bar through the switch like that, and then as you push the switch forward, the shaft will move forward. You pull the switch back, your shaft will pull back. So you could actually change your point through this slide switch. And what you could do is, underneath it you got some solder points. This is a double, you can get away with a single. And essentially on a double pole, this is a double pole, double throw switch. You've got several pins like that. Your centre pin is the common, so that would be your frog. Then you would put a black to one pin and a red to one pin. So what happens is, that is in the push forward position. So if that's pushed forward, you want black to your frog, so these two connect. If you put it back the opposite way, goes back, you've got your green and your red, and it's your red to your frog. And it is as simple as that. One little trick I have learnt, I have seen people, they've done this, they made a hole, drilled it through, put a self tapper through to hold the wire so it can move, and it works for them. That is fine. But one thing I would like to point out, which the Engaged Society suggests, is the throw on this switch, I would say, is probably a good 4 to 5 mil. The throw on your point is maybe 2.5 mil if you're lucky. So what they suggest is, if this is your point rodding, that's your point, doesn't matter how long this is, what they suggest is you put a little loop in it, and then you would go to your slide switch like that. That loop will just release a little bit of tension so that switch can go all the way back. And that is all the loop is actually there for, just so it's not putting too much pressure on your point. So that is one way of being able to control your electrofrog points. Right, if you don't understand what's going on here, electrically, you've got a switch there, you've got your switch there, and your switch there. Essentially, that will either go that way or it'll go that way, and it'll connect the red and the black. And it's as simple as that. You know your black's going to be at the front, that feeds the frog, so the wire needs to be at the front. So again, it's just sitting down, thinking about what needs to be where and how it's actually done. Like I said, I would actually solder a frog wire onto that. You're no longer relying on the point blades, and it's sending electric back that way. And that is how I've actually wired up my points. Now then, the 00 gauges make modifications to these points. What they have actually done to actually alleviate this contact here on your point blades is roughly at this point here. So if I put it, say, there, what they've done is they've cut through them tracks. So they've isolated all this. Now this bit of here and this bit here is solid. So here, if we flip it round, what they've actually done is they've cut it here, they've cut them there, and they've soldered a wire on to these two parts of the rails. So these two parts are permanently electrically connected, and a lot of modelers will swear by this, and they'll say it alleviates the issues you have with your point blades, it's getting power to your point, and then you separately control your frog. Me personally, I've looked into all the debates, and for the damage you could actually do to the point to try and make it electrically better, in my opinion, and this is just my own opinion, it's not worth it. If you feel you've got the skills to do that, then go for it, it's your model railway. Me personally, I just feed a wire into the frog, and that's how I do mine. Now the other thing you got to realise is that I will solder a wire to the frog, but of course I would use insulated joiners there to connect to your track. And again, that will be a metal joiner, that will be a metal joiner. So this is the modifications that they've actually done, and it's very much a debate. It's a very grey area whether it's worth doing or not worth doing, but that's just my opinion, that's my thoughts. So let's have a look at a unifrog point now. Right then, this is a unifrog point. Now then, difference here is an isolation point on that point there, and there's an isolation point on that point there, and you have this little wire. Right then, let's have a look from an electrical point of view what's happening with this. So you've got your plus in this side, or should I say your black, and your red. The point is going straight on. What you get here is your black and your red. And you think, okay, so that's powering straight across there, but not quite. At this point here and this point here, that whole bit there is insulated, and that is what you need this frog wire for. You need to actually change the frog. Now what they've done is, remember me saying about the modifications on the electrofrogs? You look under here, and they've actually put wires to those bits of rail. I don't know if you can see that. Let me try and bring it in a bit closer for you. Just there and there. So they are now conducted, and this is basically, this means that you're not relying on these point blades, but you've got an issue here where it's insulated. It is a little bit smaller, it's a smaller point, mind, than your traditional insulated, but it is insulated. Now then, what's going on this bottom part? If I change the point the other way, these don't change. This has still got this has still got your black, this has still got your red. On the bottom part you also have a black and a red. Look, Drop my pen now. Right then, so you've got your power coming in. You've got your black, your red, your black, your red. Right, what that means is you don't need any insulated joiners at all. You can put metal ones straight on them. You don't have to connect your frogs. You could treat it as an insulfrog. The difference is it will no longer isolate manually your sidings. You turn your point against your sidings are still going to be live. And you'll have to find another way to actually stop the current going to your sidings. Again, you got your frog. You would power that, I would say, the same way I've just shown you with the electrofrog. DCC, use your frog juicer. And if you're going manually through the tube, you can use that slide switch that I've just shown you. But that is the difference. So you've got continuous power going through that point, whichever way that blade faces. And that's the unifrog. Some people will buy these because they know they can get a light up and running. They don't have to wire those frogs in straight away, and that'll come at a later date. But if you want reliable running, it is best to wire up your frogs. So there you go, guys. That is what a unifrog point looks like. I hope that's helped some of you out.